Okay, so we're starting May 2015, paper 2, starting with question number 1. I'm going to do this question by question. In a debate on voting, a survey was conducted. The survey asked people's opinions on whether or not the minimum voting age should be reduced to 16 years of age. And we have the results. A chi-square test at the 1% significance level was conducted. The chi-square critical value of the test is 9.21. So, the first part is to state the null and the alternative hypothesis. And that's worth 2 points. So I know I'm getting 1 point for each part. So on my answer sheet, I would start with number 1. So I'm going to start with 1. Make sure I copy the number just like they have. And this was A. So section I was the null hypothesis. So I would say age and opinion are independent. The alternative is that age and opinion. Can we say that they're dependent? Not really, but we can say that age and opinion are not independent. Let's look for the next one. B. Write down the number of degrees of freedom. Now, there is a way to find this in the calculator, and I'll show that in a minute, but I wanted to also show how you can find it by hand, just for future knowledge. It's not that hard. For the degrees of freedom, it's the number of, so the degrees of freedom is found by the number of rows minus 1 times the number of columns minus 1. We have 2 rows of data and 3 columns of data. So that would be 1 times 2 is 2. And I probably would box that. C. Show that the expected frequency of those between the ages of 26 and 40 who oppose the reduction is 21.5. Okay, so to find the expected frequency there, it's going to be the row total times the column total divided by the overall total. So that's 80 times 35 divided by 130. 80 times 35 divided by 130. Now, when it says show that, you want to show your unrounded answer first. So 80 times 35 divided by 130 gives me this long thing. You want to show that before you show your rounded answer, because they say they want you to show that the answer is 21.5, and that's correct to 3 significant figures. To show that it's correct to 3 significant figures, you need to show the unrounded answer. And then you want to show 21.5. This is what you're gaining points on. Now, D actually asks you to find the chi-squared statistics and the p-value. So, this is where we enter it in the calculator. So to review putting chi-squared in the calculator, we use the matrix. So second, matrix, edit, 2 rows, 3 columns. It's actually set up correctly. 12, 20, 48, 18, 15, and 17. To run the test, it's in statistics under tests. And it's pretty far down. I believe it's C? Yes, chi-squared. It asked, did we put our observed in A? Yes, we did. Expected is in B, and we can calculate. Notice that it does give me my degrees of freedom. So on part B, we could have just wrote it down from here. D says write down the chi-squared statistic, and then write down the p-value. So D, part I, is the chi-squared calculated value. And you don't have to actually put that, I just wrote it. And you could write out the the whole thing, or correct to 3 significant figures. Second part, write down the p-value. You could write down the whole thing, or write it correct to 3 significant figures. Notice that's the difference between 3 significant figures and 3 decimal places. 0.005 is actually the first significant figure. 5, 7, that's the third one, so we round up to 3. Now in part E, we're asked whether we accept or reject the null hypothesis, and you have to state a reason. So the critical value was 9.21. That's our breaking point. If we're under that value, we're independent. So one way we could say is that since 10.3 is greater than that, what was it, 9.21, or our chi-squared calculated is greater than the chi-squared critical, since it is, we reject the null hypothesis. Now another way that we can reject it is the p-value is actually talking about the percentage, that chance that it's independent. So if we're under our significance level, which was 1%, we also reject the null. I find it easier to use the calculated value and the critical value for this. So that's what I use. So that's all for number 1.